All right, so we left off at the end of A4 yesterday. We looked at adding and subtracting complex numbers. And the very last thing I said to you was that I equals the square root of -1. And I told you that that's a definition. A definition isn't something you prove. It's like me saying to you, parallel lines don't cross. And if you said why, I'd say, well, because that's the definition of parallel lines. You can't prove that. Same with this. You can't prove that I equals the square root of -1. It's just something everybody agrees on, and we go with it. But based on that, we came up with something about I squared. Does anyone remember what I squared was equal to? Yep, -1. So anytime you have an I squared in a problem, you should never leave it in the final answer. If you leave an I squared in the final answer, I can tell you right now it's wrong. Okay? You should always simplify I squared to -1. And where you're going to see I squared come up, not when you do adding and subtracting. We didn't see it yesterday in the homework. But you're going to see it when you multiply and divide, which is today. Okay, questions on that? All right, so how do you multiply complex numbers? Well, the way you multiply complex numbers is exactly the same way you would do something like this. It's the way you'd multiply those two together. Anyone remember, sometimes there's a name some teachers used to do that? Yeah? Yeah, the double distributive property, which you can remember with this type of problem using FOIL. It means you multiply the first, outer, inner, and last. Now, we're not going to be doing it with x, we're going to be doing it with I, because that's complex numbers, but it's the same idea. So let's suppose those are our two complex numbers. When we go through an actual problem, the a and the b will have values, and so will the c and the d. Kind of like that. There's a problem where they have values filled in. To multiply these two things together, you're going to use the distributive property. FOIL is just a way to remember the order to do it. You have to do 4 multiplications. You multiply the first 2 together. Then you multiply the outer terms. Then you multiply the 2 that are inside, right next to each other. And then you multiply the last term in each parenthesis. And notice when we multiply that last term together, we're going to end up with something times I, and then another something times I. So when you multiply those together, you're going to get an I squared. That's where the I squared will come up. Let's try an example. So I want to multiply 2 plus I times 1 minus I. Now, on the test, some people do the wrong thing here. For some reason, they add it or they subtract it. Even if this word multiply wasn't here, and it just said solve this problem, how do you know this is not an addition or subtraction problem? Yeah?
Because parentheses are touching.
Yeah, the parentheses are right next to each other. They're touching without a plus or a minus between them. So you know that this is multiply, even if I don't write that word. So read the direction and make sure you do what the problem's asking you to do. Okay, so let's use the distributive property and do it out. So Dylan, what would be the first 2 things I multiply together?
2 and 1.
Yep, and 2 times 1 gives me
2.
Got that. Devin, what would be the next 2?
would be 2 times I.
2 times this I?
Oh, the negative I?
The negative I. Yep, that negative always goes with that. So 2 times negative I. And what's 2 times negative I?
Would be negative 2I.
Yeah, just like 2 times negative x would be negative 2x. Okay. Tyler, what is the next 2 we're going to multiply?
I times 1.
So there's my inner terms. And what does I times 1 give me?
I.
Just I. Make sure you try to make your i's and 1's look different. That's a problem if they look the same. And Haley, what are the last things I'm going to multiply together?
The positive I and the negative I.
Okay, so first of all, we have a positive times a negative, which is what kind of number?
Negative.
That's a negative. So a positive I times a negative I. Positive times negative is a negative. And Tyler, what's I times I going to give me?
I squared.
I squared. Now, if you leave your answer like that, there's a couple things wrong. You didn't combine like terms, and you didn't change that. So let's combine these like terms. Allie, what's negative 2i plus 1i?
Negative I.
Negative I. This minus, I'm just going to copy it down. And what did we say we can change I squared to? Yep. Negative 1. So this minus, I just clicked on, just copy down right there. This minus comes from I squared being negative 1. So you end up with 2 of them next to each other. So Ryan, what's going to happen right here?
The negative 1 turns into a positive because of the
Good.
2 minuses, yeah.
It's going to turn into a positive 1 because it's minus minus 1. So it becomes plus 1. And now we can combine that with the other number we have in the front. So 2 plus 1 gives me 3. And that's my answer. Okay, so that's how you multiply 2 complex numbers together. Okay, we'll try one more of those before we look at division. Questions on that one? Okay. Here's one more. 8 plus I times 3 plus I. Kevin, what are the first 2 things I'm going to multiply together?
8 and 3.
And that gives me how much?
I can't do this. I'm sorry. I'm having a horrible brain fog. I'm so sorry. I literally can't do this.
That's okay. Yeah.
24.
24. So 8 times 3 gives me 24. Jason, what's the next 2 I multiply?
8 times I.
Which is how much?
8I.
Yep. We got that. John, next 2?
That'd be 3 times I, and
3
I times I.
3 times I, and how much is that one?
That would be 3I.
3i. And Ariana, the last one, I times I is how much?
I squared.
I squared. And we got a little bit of work to do just to clean that up. Emma, when I combine my imaginary terms, what do I get? Yeah.
Sorry.
Oh, that's okay.
11I.
11i. 8i, 3i is 11i. And Ethan, what about this I squared? We're going to make that a negative 1. All right, so Brian, what do I get for final answer there?
You got 11i plus 23.
What if we put it in standard form?
Which one was the other? Oh, it would just be 23 plus 11i.
23 plus 11i. Yep, all answers on the test will be in standard form. Okay, questions on that? All right, so that's multiplication. So the last thing we're going to look at is division. But in order to do division, we have to know something called a conjugate. So first, let me show you what the symbol is for a conjugate, and then I'll show you how you do it. So let's say we had a complex number, I'm going to call it z. And that complex number has a real part of A and an imaginary part of B. If you put a bar above the z, it's pronounced z bar, and it stands for the conjugate of z. So that's the symbol. It's a letter with a bar on top of it. And what the conjugate is, it's a very, very simple thing to write down. It's when you take whatever you had right there and you switch it to the opposite. So if it was a plus, like it was when I started, the conjugate changes it to a minus. If it was a minus, it changes to a plus. Nothing happens to the number in front, the A. A stays exactly the same. But all you do is change the sign, which another way of saying that is negate. Negate means make the opposite. So negate the imaginary part. If it was positive, make it negative. If it was negative, make it positive. That's how you find the conjugate. So let's try a couple numbers on the left. I'll put a complex number. On the right, I want a conjugate. So what would be the conjugate of 3 plus 4i? Yep.
3 minus 4.
3 minus 4i. You take the imaginary part and you change it to the opposite. You negate it. Okay, so it becomes minus 4i. How about the conjugate of negative 8 minus 2i? Yeah.
Would it be negative 8 plus 2i?
Yep. Nothing's happening to the number in front. That stays the same. How about 5i? What would be the conjugate of 5i? Yeah.
Negative 5i?
Negative 5i. For that one, if you get kind of stuck on it, think of it like this. It's 0 plus 5i. The conjugate is 0 minus 5i. Because there's a 0 in front, we normally don't write that. How about 3? Yep.
Would it just be 3?
Just be 3. So for that one, it stays the same, because think of the original number, it's 3 plus no imaginary parts. The conjugate is 3 minus no imaginary parts. So whether you do plus 0 or minus 0, that's the same thing. So the conjugate of 3 is 3. That's how you write it. Okay, any question on finding the conjugate? All right, now let's try this. I want to multiply two numbers that are conjugates together and see what happens. So the complex number that I'm going to use is 3 minus 4i. And they want me to take that and multiply by its conjugate. So what's the conjugate? I think we did this of 3 minus 4i. Yeah? 3 plus 4i. So we're doing a multiplication problem. Which multiplying conjugates together? Let's see what happens. So Natalie, what would be the first two things I multiplied together here? Yep. And 3 times 3 gives me how much? 9. Dylan, next two.
12i.
So we had 3 times 4i, which is 12i. Tyler, the next two.
Minus 12i.
Yep. It's 3 times negative 4i is a minus 12i. And Haley, the next one is negative 4i times a positive 4i. What's a negative times a positive?
Negative 69.
So negative, and then 4 times 4 is 16. And what's on the end of that?
I squared.
I squared. What's going to happen with the terms in the middle? They cancel. And anytime you multiply conjugates together, they always cancel. So if you're multiplying conjugates, you can eliminate the O and the I step. Because whatever you get for the O step, the I step cancels it out. So all you really have to do is the first and the last. So we get 9 minus 16 with an I squared next to it. But I want to change I squared. What number can we change it to? Yep, negative 1. So now I have 9 minus 16 times negative 1. So that's really 9. And if I multiply 16 times negative 1, that's a negative 16. So what do I get for my final answer? Right?
25.
25. What doesn't that number have in it that we started?
The I.
The I. And that'll happen every time you multiply conjugates together. There will not be an I in the final answer. And you don't even have to FOIL it. The way you can quickly do a problem like this is look at the first number. The first number is a 3. Take that number and square it. The next number is a 4. Take that number and square it. Add those up, and there's your answer. You might say, well, wait, is it a negative 4 or is it a positive 4? It doesn't matter, because you're going to square it, so the negative goes away. So take whatever number you have here, square it. Take whatever number you have there, square it. Add them up, and that's the answer. So let's see if we can do this one with that shortcut. So what do you get if you square that? Yep. 25. And then what if you square that? Plus 16. And that's it. That's your answer. 25 plus 16. If you want to go ahead and FOIL the whole thing out, you can. But what happened on the last problem is going to happen on this one. So this shortcut only works if you're multiplying conjugates. If you're not multiplying conjugates, then you've got to do the whole thing from scratch. Okay. Right. Any question on that? If I have to multiply conjugates, I'm going to use this shortcut because it's less work than having to FOIL it all up. So what is the conjugate actually used for? Like why did you just go over conjugate? Because the conjugate is how you divide two complex numbers. The problem when you divide complex numbers is you are not allowed to leave I in the bottom. Just like you can't leave the square root in the bottom, you can't leave I in the bottom. So how do you get rid of an I? Well, we just saw it. If you multiply conjugates together, the I disappears. And that's what we're going to use. So in order to divide two complex numbers, the way we do it is you multiply the top and the bottom by the conjugate of what's in the bottom. So what that's going to do is it's going to cause the bottom to make all the i's disappear. Still going to have i's in the top, that's fine. But we don't want to have an I in the bottom. So multiplying the top and the bottom by the conjugate will get rid of all the i's in the bottom. All right, so we'll try two examples of dividing, and then we'll finish up with our last thing in section 5.3. All right, so they want us to divide here 1 over 3 plus 4i. Now we can't leave 3 plus 4i at the bottom. We need to cancel the I out. So what am I going to multiply the top and the bottom by to get rid of the I in the bottom? Yep.
3 minus 4i.
3 minus 4i. And the reason you can't just do it in the bottom is because whenever you do something to a fraction, you have to do it in the top and the bottom. It's like when you do something to an equation, you have to do it on both sides. Well, we have to do it on both parts. Bottom and top. Now, the bottom is quick because those are conjugates. So all I have to do is take 3 and square it. What do I get if I square 3? 9. Take 4 and square it. What do I get when I do that? 16. And that's the bottom. Now the top is a distributive property, but this time it's not a double distributive, it's a single distributive. You just have to take this number and go like that. Usually we have 2 sets of parentheses and we have to FOIL. This is only half a FOIL. Tyler, when I distribute a 1 to 3 minus 4i, what do I get?
Just 3 minus 4i.
We just get 3 minus 4i. So let's simplify what's in the bottom. 9 plus 16 gives me how much? 25. But that's not standard form. When you write an answer in standard form, it has to look like this. Real part, then you'll have either a plus or a minus, depends on the problem. An imaginary part, and then an I next to it. That's what the final answer has to look like. So to make this look like this, all you have to do is take each number in the top and divide them by 25 separately. So the real part is 3 over 25 minus, because there was a minus in front of the 4, and the imaginary part is 4 over 25. So you just take each number that's in the top, put them over the 25 separate, and that's standard form. So 3 25ths minus 4 25ths. Any question on that? Okay, I have one more with division. If people are comfortable, we can just skip it. If people want to see it, we can do it real quick. Either way, what do people think? We want to see one more with division? Okay, one more? All right, so let's do this one, and then that'll finish up division. Okay, so you can always start by going like that. Where are you not allowed to leave any i's in this problem? In the denominator. So we've got to multiply the denominator by something that gets rid of all the i's. What could you multiply the bottom by to do that? Yeah? 5 plus 12i. And if you do it in the bottom, you have to do it in the top. Okay, so let's do the bottom quick. What do you get when you square 5?
25.
And what do you get when you square 12?
144.
And if you add those together, 25 plus 144 is 169. So that part's quick, but the top part, we still have to FOIL it all up. Okay, 1 times 5 gives me 5. 1 times 12i. So let's just put that up here for a second. So that's 12i. And what's 5 times 4i? 20i. So how many i's do I end up with here?
32.
32 of them. So it's 32i. And then the last part, 4i times 12i. Well, positive times positive is a positive. What's 4 times 12? 48, but then it's an I squared. So I squared is what number? Negative 1. So it's really 48 times negative 1. So that becomes a minus 48. You could put 48i squared, but then you have to change it to negative 48. All right. Now let's just combine our like terms. What's 5 combined with a negative 48? Negative 43. And the denominator on that will be what? 169. Plus, now put the imaginary part, 32. And the denominator on that will be 169 again. Don't have to change those fractions to decimals. We can leave it just like that. Okay. Any questions on that one? So that's multiplying and dividing. So last thing we're going to look at is part of 5.3. We've talked about complex numbers. Now we're going to look at two things. First one is, how do we graph a complex? Well, graphing a complex number is very simple. First of all, the complex plane is a two-dimensional coordinate system, but it's not called x and y. X and y is what you're thinking of from a couple days ago. The complex plane has what we call a real axis and the imaginary axis. So the real axis takes the place of the x, and the imaginary axis takes the place of the y. The positive direction is to the right and up, just like an xy axis. The negative direction is to the left and down. So if you want to graph the point 2 plus 3i, let's look at that. And the first thing is, can anyone tell me what's the real part of 2 plus 3i? Yep, 2. So we have 2 on the real. And what's the imaginary part? Yeah.
3 times I.
So it's the imaginary part is how much?
I.
3. So the real part is 2. The imaginary part is 3. Graphing 2 plus 3i is just like graphing 2 comma 3. It's the same idea. go to 2 on your real axis, and then go to 3 on your imaginary axis. 2 on the real, 3 on the imaginary, and that's the point. 2 plus 3i. Right? How about this one? 4 minus 8i. How would I graph that one? Can you tell me exactly how to get there?
So you go over and say by 4, just the first positive, and then go down by 3.
Yep, so the real part is 4, and it's a positive, so you're going to go right 4, and then you're going to go down 8. Right there. So that's 4 minus 8i. How about negative 8? Where would that be? Yep.
Just to the left 8.
Yeah, just to the left 8. Think of it as negative 8 plus 0i. There's no imaginary part. There's no vertical movement. So it's just left 8. And how about 5i? Where would 5i go? Up 5. So this time, think of it as 0 plus 5i. There is no real part. There's only an imaginary part. So up 5. Any questions on graphing a complex number? Ryan, do you have your agenda?
Oh, yeah. Sorry. Thank you.
Thank you. Now, the reason I showed you how to graph complex numbers, you're going to see next. So the last thing we're going to look at is how do you write a complex number like this. That's called standard form or rectangular form. How do you write that in polar? Well, it's going to be the same way we learned how to write things in polar on Monday. What are the 2 things that you need to write something in polar? Yep.
Radius and
Yep, you need the radius and you need theta. So we're going to do it pretty much the same way. Okay. So let's see how we do it. So again, I've used this letter before, but Z is usually the letter you use when you want to represent a complex number. And Z has 2 parts to it. It has a real part and it has an imaginary part. Now, I know I normally put the I second. The only reason I'm putting the I first is because if you look at the page in your book, they have a formula, and by doing it this way, it's going to match what they do in the book. Okay. But it technically doesn't matter where you put the I. That's not standard form to put the I in front, but for what we're doing, it's fine. And I also use the letters X and Y to help kind of make that connection. X is the real axis, is the real number, and that's horizontal. Y is the vertical, and that's your imaginary. So I want you to remember that X is always the real, and Y always goes with the imaginary. So that's rectangular form. That's the way you've been writing complex numbers all week so far, yesterday and today. Now we're going to look at how can we change that to polar. And we already have all the formulas we need to do it for Monday and Tuesday. We don't have to reinvent any formulas. Does anyone remember on Monday we had a formula for X and we had a formula for Y. They each involved a different trig function. Does anyone remember what the formula for X was when we're converting between polar and rectangular? Yeah.
Wasn't it R cosine theta?
Mm-hmm. So this is your formula for x, and anyone else remember the formula for y? Jason?
R sine theta.
Yep. R sine theta. So in order to write a complex number in polar, we're going to make two substitutions. Instead of x, you're going to substitute in the formula we came up with on Monday. So change x to r cosine theta. Instead of a y, change y to the other formula we came up with on Monday, r sine theta. Let's write that down. So you're going to have r cosine theta plus the I is going to stay right where it is. And then change y to r sine theta. Now we can shorten that a little bit, not a lot, but a little. If you look at both terms, the one on the left and then the one on the right, what do they both have in common in front of the trig function? The r. Whenever two things have the same thing in common and there's an addition sign between them, you can factor that thing out, so you only have to write it once instead of twice. So if we factor out the r, what would be left in the first term? Just cosine theta. Plus, and what about if you factor r out from that second term? I sine theta. And that is the polar form, same thing I just wrote, of a complex number. That's how you write a complex number in polar. R cosine theta plus I sine theta. So, two things you have to solve for here. You have to find r, and you have to find theta. That's what you did in the homework last night. To find r, use the Pythagorean theorem. I'm not going to write it again. You got it in your notes from yesterday. R squared equals x squared plus y squared. How do you find theta? Well, it depends. It depends on what quadrant you're in. If you're in quadrants 1 and 4, you're going to do the inverse tangent of y over x. If you're in quadrants 2 and 3, you're still going to do the inverse tangent, but what do you have to add to it? Yep. If you're doing it in degrees, you have to add 180. So how you find the r and the theta here is exactly the same way you did them in the homework last night. There's no difference. So an example of what a final answer would look like if you write a complex number in polar is this. Just making this up. 6 cosine 25 degrees plus I sine 25 degrees. That's an example of a final answer. You don't do anything else with that. You just stop right there. And that's what you'd write down. All right, so let's try an example and see if we can figure out those two things based on problem. Okay, this will be our last one. Okay, they want us to write this complex number in polar. Now, first of all, they didn't put a number in front of I this time. So what number is always in front of I if they don't write it? Right. If you want to put the 1 there so you can see the x value and the y value, you can do that. All right. let's graph that complex number. Not looking for an exact picture, I'm looking for a quadrant. What quadrant is square root 3 minus 1i in? If you were to do it just like we did these right here. Yep, it's in quadrant 4. It's positive, which means go to the right. Negative, which means to go down. Okay. So let's find our angle. What's the formula we use to get the angle if you're in quadrant 4? Devin?
Is it inverse tangent y over x?
Inverse tangent y over x. Let's see what that is. So inverse tangent of y divided by x, negative 30 degrees. The problem didn't say this, but if they did ask for a positive angle, instead of going this way, negative 30, that's the same as going the other way, how much? 330. So just like we learned earlier, there's 4 different ways to do it. There's still 4 different ways to write this. All right, so let's go with this as our angle. And now we need to find our radius. That's the distance from here to that point. Can anyone set up my formula to find the radius? Yeah.
Isn't it r squared equals the square root of 3 to it's squared 2, and then minus 1i squared, or plus 1i squared?
So it is a plus. Yep. And what's always inside here? What letter? Like when we write. Say it again.
Would that be the I?
No, the R is over here. What's our formula without any numbers in it? R squared equals
X squared plus y squared.
y squared. Yeah. This is x squared. This is y squared. The I is not part of anything.
Okay.
So what would you put inside the parentheses there?
Negative 1 squared.
Negative 1 squared. So r squared equals, what's the square root of 3 squared? 3. What's negative 1 squared?
Could it still be negative?
What's negative 1 times negative 1?
Oh, 1.
1. Yeah. So what does that give me for a radius?
4.
Careful, not 4.
Or 2 of that.
2. Okay. So here's your radius. Here's your angle. Just take those 2 numbers, fill them in these spots, and that's your final answer. So it's r cosine theta plus I sine theta. So it's r cosine 330 plus I sine 330. That's the final answer. If you tried to do anything with that, if you said, well, should I take the cosine of 330 and then distribute this 2 out? You could, but what you'd be doing is changing it back to what you started with. So if you do that out, you're going back again. So we don't want to do it out. Just leave it like that. Okay. Any questions on that? So that's the homework for tonight. And things you would want to make sure you know for the test. All right, so first thing we did was graph in polar. So plotting a point. Convert between polar and rectangular. That includes going polar to rectangular and the other way, rectangular to polar. We did complex arithmetic.
Do we have a reference sheet for this?
Yes.
No.
So complex arithmetic would include add. Question? Add, subtract, multiply, divide. So you'll have one of each. Graphing in the complex plane. That's what we just did about 10 minutes ago. Graphing in the complex plane. And writing a complex number in polar. That's the last example I just did. So those are the topics that will be on the test.